Good morning, students. That today we are continuing with the second chapter and salt. Today we will discuss about the activity 2.10. From a 2.10 activity, that is the most important question is that while diluting an acid, why it is recommended that acid should be added in water, not the water in an acid. Firstly, what is the meaning of a diluting? Dilution means that is a mixture of water and acid. In excess quantity, that is we should add the water, and in a less quantity, that is acid will be there. The question that acid should be added in a water. Firstly, we take a beaker. In a beaker, two options are there. That is, firstly we take a water, and we have added acid. Any acid will be there. Clear? Second one is we have to take acid in a beaker and water should be added. Two possibilities are there. Either we should have acid, add the acid in a water or the water in a acid. But while diluting, we should always add acid in a water. We should add acid in a water, not water in a acid. Why? Give reason. Clear? We should always add acid in a water, because when we add acid in a water, it is a highly exothermic reaction. But why? That is because when we are adding the water, acid in a water, it is a highly exothermic reaction. If we add water in an acid, then the solution will be splashed out, and it will be the chances of burning. Clear? So that's why we should always add acid in a water. If we add water in a acid, it is a highly exothermic reaction. Highly exothermic means a lot of energy is released, and solution of that container is splashed out, and there will be the chances of burning. Even our skin will be burned. So that's why we should always add acid in a water by small amount. Why? Constant stirring. Clear? This is about activity 2.10. The next topic is how strong are the acid and bases. Firstly, we know that is what are the acid and what are the bases. That is by the different method, by the tasting or by the H positive ion or the OH negative ion. That is the acid give H positive ion and the base give OH negative ion. From that we have considered that is the acid and bases. Now next question is that how strong are the acid and bases? How can we detect that is your acid is strong or the weak? Yes. That is how strong acid and the bases are. We know about the universal indicator. We know about the acid and bases. How the strong acid and bases are, that is by the universal indicator or by using pH scale. Okay. pH, full form of a pH is your potential of hydrogen. In which amount that is the hydrogen is present. That is why using universal indicator or a pH scale value, that is we know about the how stronger that acid or bases are. And that is the value of a pH scale value, this one. That lies from 0 to 40. Yes, pH scale value, that is in the form of a scale. Also we can get and also in the form of a solution, that is called universal indicator. And here the meat is 7. 7 is called Newton. neutral if the value of any solution is 7. It means that is neutral. So how can we detect that is we have discussed if the value of that 0 to 7 it means that is acidic in 0 to 7. If the value is less than 7. If the value of a solution is more than 7 to 40, then the nature of a solution is this. Clear? Firstly, if the value is 7, it means that solution is neutral. If 0 to 7 variation is there, then it means acidic. If 7.1 more than 7 to 14, that means solution is basic. Now, at a 7, that is we get a green color. If they have a neutral solution and the nature of that solution is neutral, neither the acidic nor the basic, it means we get a green color. If now 0 to 7, if about 3, 0 to 3, it means that is a strong acid. If value is 3 to 7, it means weak acid. Clear? If there is a weak acidic, it means we get a orange color. The color of a solution is we get that is of a orange color. If the solution is strong acidic, okay, it means we get a red color. Clear? That they gives different colors while we are putting the acidic and basic in that universally indicator that is of a green color. Clear? If we put acid and base, then they give a different color. If that solution is a strong acid, it means they give a red color. And from that we can know that that is a stronger acid. If they give orange color, it means that is of acidic nature, but that is the weak acid. Now talking about the base. Base is 7 to 14. If that is more than 9, it means strong base. If more than 7 or about 7 level, okay, then weak base. If they have a weak base, then it gives the violet color. Or we can say that they give purple or blue color. But if they have a strong base, they give a dark blue color, dark violet color. Clear? From this table is clear the pH scale value. pH scale values lies from a 0 to 14. That is of a universal indicator of the pH scale. Universal indicator have a green color. If they have a green color, we put some solution in that. That color does not change. It means that solution has a neutral, neither the acidic nor the basic. If they give green red color, then it means a strong acid. If they give orange color, then we can say that they have a weak acid. If they give the bluish color, okay, it means that is a weak acid. If they give the dark violet color, it means that are a strong base. Now, what is the definition of a universal indicator? That a universal indicator is the indicator that tells about the nature of a solution, that is the acidic or the basic, by changing their color. Now, if they have a strong acid, then they have a more H positive ion. If they have a weak acid, then less amount of H positive ion. If they have a weak base, then less amount of OH negative ion. Because OH negative ion is common in them, in that they have a less amount. But in a strong base, that is a more amount of OH negative ion. Clear? This is about the universal indicator of the pH scale value. Now, if I ask you a question, if we are adding water in acid, if we are adding the water in acid, means the amount of acid is less, but the water is added in a large amount, then the solution become weak acid. We are taking 2 ml of acid, but we are adding the 10 amount of 10 ml of water. Then dilution of acid is more. It means that is a strong, weak acid. In that weak acid, they give a more the about the 4 to 7 value. But it means also that in that have a less amount of H positive ion. Next question is water plus base. Now, if we take a less amount of our water but more amount of our base, then the nature of a solution is basic. Obviously, we are adding water in a base, then the solution is basic nature. But that solution is of a stronger base or the weak base. That is a more amount. Base is of a more amount and water is in a less amount. Then the solution becomes base and that is a stronger base. And in a strong base, according to the concentration, in that have a OH negative ion is more. They give a more OH negative ions. Clear? On the basis of a concentration, if they have a strong base, they have more OH negative ion. If they have a weak acid, they have a less amount of OH negative ion and vice versa. And according to the color, if they have a stronger acid, they give a red color. If they have a weak, they give about a orange color. And if they have a weak base, they give bluish color. And if they have a strong base, they give a violet color. Clear? This is about the universal indicator. How can we detect that is the solution is a stronger acid or the weak acid, strong base or the weak base? By using a universal indicator or the pH scale. And the pH scale is percentage of hydrogen. Next topic is the importance of pH in our daily life. That is the pH have a very important play a very important role in our daily life. That we have discussed. Firstly, our plants and animals are pH sensitive. pH sensitive means they have a that is animals and plants that is have pH range that is 7 to 7.8. Mostly that is plants and animals are the pH sensitive. They have about their own pH range. On that pH scale they will live. And that have a pH range is 7 to 7.8. Mostly that is the plants and animals they require water. If the water is acidic, now there is a lot of pollution around us, and in that cases that is the rain become more acidic, and acidic rain have pH value 5 to 5.6 nearby. Now that water, acidic water is also fall into the rivers. Clear? If the acidic rain, acidic water fall into the river, then the River water have also decreases its pH range, means that become acidic. Understand this topic? Firstly, that is the plants and animals have a pH range that is 7 to 7.8. They live about in this pH range that is more specific to live. But if the rain is very acidic, it means in that rain a lot of pollution are there. They become acidic. Means they have a large amount of acid. And that rain has that acidic rain have a pH values about 5 to 5.6. Now if we are adding the acidic rain in river, then that water become acidic, means pH value is decreases, and that is very difficult to live for the aquatic animals and plants. So that's why we are saying that plants and animals are also pH sensitive. They have a specific pH value to live in a water. Second one is, what is the pH of a soil in your backyard? Backyard means our field, khet. Clear now we firstly discussed that is the plants have their own pH value to growth. If their pH value is decreases, now we are continuously cultivating the crops. So continuously cultivating the crops, that is the pH value of a soil is decreases. So, to increase the pH value of a soil, that is, we should add calcium carbonate or calcium oxide or calcium hydroxide. Now, we have already discussed that is the acidic plus base that gives to salt and water. That action is called neutralization reaction. In each and every question, that is, we have to neutralize. Now the acidic soil here comes acidic, that have a lesser pH value due to some reason, due to the continuously cultivating, due to the acid rain. Okay, what should we do to neutralize that effect? Okay, we should add, that is the calcium carbonate, calcium oxide, and calcium hydroxide. We should add, these have a nature basic, and your soil become acidic soil. Then we should add base to neutralize that effect. Yeah, what we should do, that is to neutralize the acidic effect of our soil. Then we should add either calcium carbonate or calcium oxide or a calcium hydroxide, because that have a basic nature. If they have a basic nature, they neutralize the effect of that acid formed in a soil. The next question is, the next question is the importance of a pH in our daily life. We are doing this topic under this pH in our digestive system. You know very well that is in our stomach, that is the hydrochloric acid is present. Clear, that is the HCl. HCl is present in our digestive, in our stomach. But when we are doing the overeating, if we are eating excess, then mostly that is acidity is formed in our stomach due to the overeating. That is our stomach become acidic. Now, what we should do to neutralize that effect, and to neutralize that effect, we use a baking soda and that of a basic nature. Yeah. If you your parents sometimes you have listened in your home that acidity is formed in our stomach, in our parents' stomach. Then what we should do? Why this is happen? Clear, this is happening because of overeating. Clear, and what we should do? That is, we should add small amount of baking soda. Our stomach become more acidic. We should use baking soda that is of a basic nature that will neutralize that effect that is formed in our stomach. Okay? Also, that is what is how the neutralization reaction is important in our daily life. That if in any cause that is acidity is formed, then we should have base. In a different types of acidity, we should use different type of base to neutralize that effect. In a case of your backyard, that we should use a base calcium carbonate, calcium oxide, and calcium hydroxide. But if the acidity is formed in our stomach, then which base is used? That we should use the baking soda to neutralize that effect. The next question is that pH change as the cause of a tooth decay. Now, our tooth enamel is made up of calcium phosphate. That is about a half marks question is that from which that is our tooth enamel is made up of. That is tooth enamel is made up of calcium phosphate. And pH range or our mouth is 5.5. Means our mouth become small amount of acidic. But when we are continuously eating and we are not doing the brush, then our tooth become decay, that become spoil, and many problems are in tooth. What will be the reason? How can we remove? Then if we are continuously eating the sticky food like the chocolate, ice creams, then our mouth become more acidic. Clear? Our mouth become more acidic. Then what we should use? Base. And which base we have used? Fluoride. That you have to check that is any toothpaste we have to use. That is in that fluoride is mentioned. We'll check today that toothpaste is present at your home. That is in that fluoride base is present. Fluoride have a nature basic. When we are doing the brush, then that neutralize the effect of that acid. Yes, that neutralizes that effect from the acidic effect that formed in our mouth. Okay, which base we have to use? That is the fluoride. Now the important question is tooth enamel has a made up of a calcium phosphate and pH range of our mouth is a small amount of acidic that is about 5.5. In a some continuously eating or a sticky food that is our mouth become acidic and pH value is decreases. What we should have do? We should do the brush. In our toothpaste that is a base is present. Which base is present? Fluoride base is present to neutralize that effect that is formed in our mouth. Clear? So that's why we should have do the brush daily. Now, next importance is that self-defense by the animals, plants, or the chemical welfare. And if any honeybees sting you, then what will you do? Why we feel irritation or a pain? The honeybee is sting you, then why we feel pain or why we feel irrigation? How can we defend? We can how we protect them. comma that irrigation or a pay. Clear? In a nettle of leaves or sting of honey, if the any leaf sting you had any honeybee sting you, then in the nettle of a leaf and the sting of a honeybee, a acid is present. Which acid is present? That is the methanoic acid or formic acid. That is in the nettle of a leaf or the sting of a honeybee. That is a methanoic acid, or we can say that formic acid is present. And what is the formula of this HCOOH? That is the most important question. That is in the sting of a honeybee, which acid is present? That is, we use a word that is the methanoic acid, formic acid, and we also mention the chemical formula. That is HCOOH. That is formula of methanoic acid. Then what we should do? Then in the nettle of our leaves or the sting of a honeybee, that is acid is present. So that's why we are feeling the irritation or pain. Now what we should use? Then we should use base. Now in that, which type of a base we use? That is a baking soda. Baking soda is we have to rub the baking soda on that particular part. Then that neutralize that effect that is formed by the nettle of a leaf or the sting of a honey. Clear? How can we defense? We can defense by using the baking soda, by rubbing the baking soda on a particular space. That neutralize the effect of a that acid. Which acid is present in a sting of a honeybee or the nettle leaf? That is a methanoic acid, formic acid. That is the formula is HCCOH. That neutralize the effect of that acid formed that in a particular fish. These are the most important questions. Importance of a pH value, or how can neutralize neutralization reactions uh, uh, importance of important in our daily life. Clear? Thank you for today. Good morning, students. That today we are continuous with the second chapter, that is the acid, base, and salt. Today we will discuss about the activity 2.10. From a 2.10 activity, that is the most important question is that while diluting an acid, why it is recommended that acid should be added